Hey guys, it's Mr. Nakami here. Hopefully today we get to finish up 6.3. Hopefully you're feeling a little bit more confident as well with confidence intervals. Today we're going to talk about how we can make our confidence intervals more accurate without losing out on anything, right? And one way we can do that is to increase the minimum sample size, the number of people you need to survey, right, to make sure, or that you need to survey, that you need to sample to make sure that you will have this precision of a confidence interval without decreasing the level of confidence, right? And to do this, it's very simple, right? So you do a little bit of algebra and you pretty much just solve for n, but they give you the formula right here. It's this guy right here. That n will be telling you what your sample size needs to be if you want a specific confidence level with a specific margin of error, right? Now, for this to work, if you do not know what your p-hat is or your point estimate for the probability of success, you can just use p to be equal to 0.5 and q to be equal to 0.5, like a 50-50 chance, right? 50%, 50%. If you do know what it is, then you substitute those values in instead, okay? Z critical is the same thing as what we've been doing this whole time, right? You have a confidence level of C, you just look up Z critical, and then you divide by the margin of error. The margin of error is going to be a little bit tricky. It's what's your plus or minus, your give or take, or your within range. That's usually the key word that you're going to be looking for in your word problem, right? It's usually within something, within, right? And that will help you to find your margin of error for the problem. Let's go ahead and take a look at the problem right here. You're running a political campaign and wish to estimate with 95% confidence, right? So C is equal to 95%. The proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. So your margin of error in this case is going to be 0.03. Find the minimum sample size needed if no preliminary estimate is available. If no preliminary estimate is available, that tells us that p hat we're going to assume is 0.5 and q hat is equal to 0.5. So now I have my 3 out of my 4 pieces of information that I need to find my n, right? I got my p hat, I got my q hat, I have my margin of error. The only thing I don't have is my z critical, right? But I do have my c is equal to 0.95, and I know this is a normal distribution problem, so I'm going to go ahead and look at my z table, right? And it was, I believe, I already forgot what it was 95%. So I'm going to go ahead and look that up on my table right here. 95% for my confidence level, which gives me a z critical of 1.96, right? So that tells me Z critical is 1.96. All I gotta do now is just plug all those pieces of information into this equation right here. So my minimum sample size needs to be equal to my p hat, which is 0.5, times my q hat, which is 0.5, times Z critical, which is 1.96, divided by my margin of error, which is 0.03. And this is all being squared. And you just plug this into your calculator, right? So on my calculator here, I'm going to go ahead and plug that in. This is 0.5 times 0.5 times 1.96 divided by 0.03. And this whole thing is going to be squared, right? And that gives me a fairly large number, right? This is telling me that the minimum sample size I need, right? The amount of people I need to survey is approximately 1067.1 repeating. 1067.1 repeating. Which means if I want it to be truly accurate, I'd probably go a little bit higher, like just 1068, right? Because you can't really survey 0.1 of a person, right? Now, how does this vary if you know what p hat is? Now, your margin of error and your z critical will still be the same, right? It's still 0.03 and z critical is 1.96. But your p hat now is 0.31, and that tells me that your q hat is going to be 1 minus that, right? Remember? So q hat is just going to be equal to 0.69, we just take that, we plug that in, and it's the same equation, but now you have a different p hat and a different q hat. So n is equal to p hat, which is 0.31, times q hat, which is 0.69, and everything else stays relatively the same in this problem. It will be 1.96 for z critical, and your margin of error is still 0.3. Again, it's that whole idea of understanding that it's within 3%. That's what your margin of error is. It's plus or minus 3%. Right? We're going to square that, and we just plug this into the calculator again. 0.31, right, times 0.69 times 1.96 divided by 0.03. And we go ahead and square that. And that tells us that our sample size needs to be 913.02. And is equal to 913.02, and that's what our minimum sample size needs to be in order for us to have a 95% confidence interval within 3%. All right, so that's pretty much it. That's going to finish up this chapter, the section, not this chapter. This is section 3 of chapter 6. You guys have a example problem I want you guys to try. It's very similar to this. It's in your notes. Go ahead and finish this off and submit it on Canvas. And then after that, you do have a homework assignment that is due, I think, in a week. All right, so go ahead and I'll have that posted so you guys can take a look at the problems. You should practice these out, how to calculate, construct your confidence intervals, and also how to calculate the minimum sample size you'll need. All right, and that's it for this section. All right, and we'll continue on with the next section. And after that, I believe our test is coming up soon. All right. Hopefully you guys have a good rest of your day. All right. See you later.